So very last class. The good news is there's nothing new to learn. All we're going to do today is just go over what's on the exam. I'm going to show you examples of what all the questions are going to look like and work through one or two of them. So here's the structure of the exam. Here's what it's going to be. 70 points in total, 26 symbolizations, there's 2 short answer questions worth two apiece. There'll be some invalidities and expansions, and there's going to be 4 derivations worth 26 points each. Yeah? Okay, so we're just going to go through these different sections one by one, talk a little bit about what they'll look like. I'll show you what the instructions are going to look like and talk about what answers should look like. Unless there's any questions before we dive in? Okay. Okay, so here's the prompt for the symbolizations. Symbolize the following sentences using the symbolization scheme provided. You've seen this. This is what it looked like on test 1 and test 2. Here's what the questions are going to look like. So we've got every boy gave a treat to some dog he liked. So that's the sentence to be symbolized, and then the symbolization scheme below. You see that the predicates now come with these little numbers. So B1, 1 indicates that it's a 1-place predicate, 2 indicates a 2-place predicate, and 3 a 3-place predicate. If you see a 0 after 1, that's indicating that it's a name, not a predicate. If it says a little lowercase b and 0, that's indicating that that's supposed to act as a name in that sentence. Is that pretty clear? Okay, do you want to do this example? Let's do the example. Okay. Good. So, every boy gave a treat to some dog he liked. So recall the strategy that I recommended to you for dealing with symbolizations, especially multi-place symbolizations, which was start with figure out how you're going to place the variables in your most complex predicates, and then kind of work backwards from there. Arrange the sentence around how you're going to make the variables end up. So let's start with there's a 3-place predicate here. Let's start with a 3-place predicate. So G says A gave B to C. So I'm just going to say, I'm going to make G, X, Y, Z. And that means that A gave B to C. The boy gave a treat to some dog he liked. That means that X is going to be a boy. Y is going to be a treat, because that's what the boy gave. And Z is going to be a dog. A gave B to C. X, the boy, gave a treat to the dog. Yeah? Okay, and then using the same way of assigning variables to objects, I'll just do this other. So we got a 2-place predicate in here as well. So that means that L is going to end up being A liked B, the boy liked the dog. So just going to refer to this chart again and say X liked, not Y, Z. Okay, so what I know is that I'm going to end up placing those variables into those predicates. Of course, I've got to give quantifiers for those variables. You never want to end up with a variable that doesn't get associated with a quantifier in these symbolizations. So it's just a matter of placing the quantifiers and the predicates in the right order to make those complex things make sense. Yeah? Okay, so let's do that. So we've got every boy did a thing. So we're going to say, for all, and our boy is X, for all X, something, 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 right? So for everything, if it's a boy, then something, something, something. He gave a treat to some dog he liked. We need quantifiers for both of those variables, so we'll start with the treats. There exists something such that it's a treat, and there exists something, EZ, such that it's a dog, and the boy liked the dog, L, XZ, and he gave the treat to the dog. Oh, G, X, Y, Z. bracket, a bracket, and a bracket. How's that look? That make sense? Yeah.
Could you have put in their existence? Is that right after their existence? Why?
Yes. Yes. So here's another perfectly good way of writing this out. So suppose we've got for all x, bx, then there exists a y and there exists a z such that ey and dz and lxz and gxyz. I'm told math people prefer to do it this way to get their quantifiers out front. For some reason, that's easier for them. That's a perfectly valid way of symbolizing these things. There's nothing logically wrong with that. Yeah? Any questions about that? Hopefully this is review. Hopefully this is stuff that we've done before. We're just doing one more example. There is one thing that I'd like to, if there's no questions about this, there is one thing I'd like to just flag. There's a couple of questions on the exam, I believe, where it's got a sentence like the following: everything, something, something, something. So how do we symbolize the sentence, everything is better than your band? It's a terrible, cruel thing to say to somebody. But you might worry that there's no predicate for being a thing. I'm just going to stipulate that you don't need a predicate for that. So here's how I would symbolize this. So for all x, and maybe we could just do it this way. For all x and for all y, if x is your band, then be yx. Or just another way of doing that, for all x, if ax, then for all y, be yx. So we didn't use a predicate to say that something is a thing. I assume that everything is a thing. Yeah? Just assume, you don't have to say that it's a thing, just assume that everything that you could plug in is a thing. Does that sound fair? Reasonable enough? So if you were trying to symbolize everything, you just say for all x. Clear? I think there are two symbolization questions where something like this shows up, where I use the term thing. And you might be like, oh no, there's no predicate for thing. Just symbolize it like this. Just say for all x. Or for all y in this case. Okay? So now you know, logically speaking, how to formalize trashing your friend's band. Yeah?
Does that mean the band can be better than itself?
Yes, in this case we would have to add, so I didn't think of this implication. What we would need to do is say, we'd need the identity relation. So we'd say if x does not equal y, then be yx. This is, again, a thing I didn't teach you. It's a part of our logical system, identity and non-identity. This is not, there'll be no questions where you need to use identity on the test, I promise. Huh? Yeah?
Isn't it just not a y, because the predicate of a is your band, right?
Oh, if it's not a y. Interesting, yeah. For all x, if it's not the case that we're talking about, wait, a y? If it's not a y?
Right. Because the predicate is your band.
Oh yeah, you could do it that way, yeah. For everything, if it's not your band, then that thing is better than your band. Good, yeah, that would work too. Yeah. Okay. The point of this example, without getting into weird stuff that we haven't learned, was just that you can symbolize x as a thing by just saying x. Just assume that everything is a thing. Okay? Okay. So there are a number of regular symbolization questions, and there's going to be 2 questions of the following form, ambiguous symbolizations. These are symbolization questions where we'll say, the following sentences are ambiguous, write out 2 good symbolizations of them using the symbolization schemes provided. They should be not logically equivalent symbolizations. So when I say 2, I mean not logically identical. I mean, they should be 2 different sentences, 2 different meanings of the potential meanings of the sentence. Is that clear? So you can't just write out 2 logically equivalent versions of the same thing. Okay, let's do this example. So here's what it'll look like. I'm just going to give you the sentence and 1 symbolization scheme, and then you write out 2 symbolizations of it. Okay, so let's do this one. Someone will clean up all of the messes. That could be a bit larger, but you get the picture. Okay, so first thing to do is, of course, figure out the way in which the sentence is ambiguous. You have to decide figure out what the ambiguity is, and then you can symbolize it in both ways. So, which way is this sentence ambiguous? It could be, yeah.
Is the cleaner specific or general?
Perfect, yeah. So is it the case that there is one specific person who's going to clean up all of the messes in the universe of discourse? Or is it the case that for any given mess, there's at least one person such that that person is going to clean it up? All of the ambiguities that I'm going to give you here are ambiguities of scope ambiguities. So it's just the stuff that we learned about putting existentials inside universals or universals inside existentials. Those are the ambiguities we're going to be dealing with, not just some weird ambiguity you've never seen before in your life. So let's see what we got here. So C, X, Y, where X is a person and Y is a mess. And that's going to work for both of our, we'll use this sort of schema for both of our symbolizations. Okay, so to symbolize that there is a person that's going to clean up one specific person that's going to clean up all the messes, we give the existential wide scope. So we're going to say there exists some person such that, first of all, they're a person, and for all of the messes, by, then C, X, Y. Bracket, bracket. Giving the existential wide scope means we're talking about a specific thing. Right? Okay? So now how will we symbolize it if we want to say that there is at least one, for any given mess, there's at least one person that cleans up that mess? A far more plausible statement. We just flip the order of the quantifiers, right? So we give the universal wide scope. So for all Y, and we still want to keep it Y because we decided already that Y is our mess. So for all Y, if Y is a mess, then there exists at least one thing such that that thing is a person, and that person cleans up the mess. 3. Yeah? Questions about that? So that would be, assuming that I did this symbolization right, and I don't see any clever hands to help me out showing me that I didn't do it right, so let's assume that I did. That would be the complete answer for this question. Just two separate symbolizations that capture the different ways that the scope ambiguity could go. How's that? Yeah?
Would someone get full marks on the exam for having one of the two?
No, that's the whole point of these two. So there's 2 of these questions, 2 ambiguous symbolization questions, and on those 2 questions, those are the only ones that I've made intentionally ambiguous. You get full marks for giving both of the symbolizations. Yeah?
Will it say specifically which ones they are?
Yeah. So it'll be very clearly marked. You start it with a bunch of regular symbolizations, and then there's a new section that looks like So it'll say this. The following sentences are ambiguous, write out 2 good symbolizations of them. That's not to say that I've been completely successful in making the regular symbolizations non-ambiguous. We've tried, of course, but as per usual policy, if there's an ambiguous symbolization in the regular symbolization questions, both answers will be accepted. And we will collaborate hard to make sure that that happens. Okay. How's that? Yeah. So there's 4 points each, and you get 2 points for each of the 2 ways of symbolizing it. And there's 2, so there's 2 sentences. So I give you this sentence, you give me 2 symbolizations. There's 2 of those. So there's 4 in total, I guess. But yeah. Other questions? Okay, good. Okay. Now, the most dreaded question of all, short answer. I know you hate this, partly why I put it on the thing, to test the variety of skills that you'll have. So I can't give you a whole bunch of examples of these because I've tried to make the questions, there's 2 of them, as central as possible. So these are not weird, obscure questions that we haven't touched on at all in class. They'll be things that I've talked about extensively. So for example, explain why it's okay. This is actually less central than the questions on the actual exam. This is a slightly more niche question than the ones you'll be seeing. But this is the style of thing that I'll show you. Yeah? So what I recommend, they both start with the word explain. Explain is a strong term. Explain means give me the reasoning. It doesn't just mean say a definition. Yeah? So explain in detail, be as pedantic and specific as possible, and then you'll get full marks. Questions about this one? It's bizarre to me, coming from a philosophy background, that you would consider, most people in this class will consider this to be a more devious and difficult question than derivations, which I find exceptionally hard. I find that to be the most difficult part of this course, and then this would be trivial, of course. You just know some stuff and understand what you're doing. So have a basic grasp of the main, like know what validity is, know what a derivation is, know what a subderivation is, know what a mixed derivation is. Those are the kind of I take it really central concepts that I'll be asking you about, and it's just to explain what you've been doing all semester. Yeah? Questions about that? Yeah? What is the answer to this question? So the answer to this question is, actually, this wouldn't make a great, the answer to this question is kind of long and complicated. So I don't think this would, one of the reasons why I wouldn't put this question specifically on the exam is it's a bit long and complicated. I'm expecting questions that you can answer with a couple sentences. But if I was answering this, if I had put this on the exam, if I was answering this question, I would say something like, when you've started a conditional derivation, you're trying to prove the validity of inferring the conditional's truth. And if you've shown a contradiction, then you've shown that it's impossible for the argument for the validity's truth, the conditional's truth, to be invalid, because validity is the impossibility of the premises being true and the consequent being false, or the conclusion being false. Therefore, showing a contradiction in the premises guarantees the validity of the argument. Something like that. If you would like more on this specific question, this is not going to be on this question is not on the exam, but if you'd like more on this specific question, there's some lecture bits on it. When I first introduce ID and CD, I do go over this question. Yeah. Other questions about the short answers? Okay, it's only 4 points. It's on really central topics. These are not trick questions. Okay, moving on. Okay, so here's what your invalidities are going to look like. So there's a few invalidities, 2 points apiece, and what I'm going to give you is an argument. normal form of an argument, and then a little thing that says UD and a little thing for each of the predicates. And your job is just to fill in what the universe of discourse is and what should go under the predicates. Yeah? So this is exactly the form that it will take on the exam. So let's work through this example quickly, shall we? Here we go. OK, so you will already have written out the letters UD, colon, and a list of the predicates. We got F, G, and H. And your job is simply to tell me what goes in there. OK. So I make notes for myself. Got to make this true, this true, and make this false. OK. So the single place invalidities, I think you can kind of work through in your head. I find this to be not impossible to do, just sort of looking at it and figuring it out part by part. Assume that there must be at least one object in the universe. You're not allowed to assume 0 objects. You must have at least one object, as before. So assume there's at least one object in the universe. In this case, we've got there exists something with the property F. There exists something with the property G. I would point out that the conclusion that we need to make false is that there's something with both the property F and the property G. So we need to put something under the F predicate and something under the G predicate, but they can't be the same thing. So what that tells me is that I need at least 2 objects in my universe of discourse. Right? So let's make premise 1 true by saying 0 has the F predicate. So good there. Let's make premise 2 true by saying G has the F predicate. Very good. So 1 is true, 2 is true. Now we just go through and ask ourselves, are the rest of them true? So for anything, if it has the H property, then it has the F property. Well, currently nothing has the H property. So we could just leave H blank and get that to be true. Or you could put an object there. So we could specifically put 0 there. So if 0 has the H property, 0 is the only thing that has the H property. It also has the F property. That comes out as true. And premise 3, for all x, biconditional between fx and not gx. This tells us if anything has the F property, it has to not have the G property, and vice versa. And is that currently true? If anything has F, 0 has F, does 0 have G? No. And if anything fails to have G, like 0, does it have F? Yes. Because we only got 2 things. If we had 3 objects in our universe, suddenly this biconditional would fail to be true, because for 2, not G is true, but it's not false for F. So we just leave it like that. OK? And that's it. We're done. Close those brackets to indicate that those are completed sets. Ta-da. Questions about invalidities? Yeah.
Do you have any truth table questions?
No truth tables. No truth tables. Yeah. No, we left that behind in the land of sentential logic. Yeah. This is the kind of predicate logic equivalent of the truth tables. This is basically what doing many of the same things with this as with truth tables. Yeah. Yeah. That's right, yeah. So all the symbolizations and derivations will be multiplace. So a common question about this stuff is the exam cumulative? And I have to give you the very logical, non-logical answer that sort of. Because in some sense, I'm just testing you on what we've done since test 2, just the multiplace stuff. But in order to do multiplace symbolization and derivation, of course, you need all the skills from single place and all the skills from sentential logic, except truth tables. So it's kind of cumulative. Yeah?
But some things like truth tables are omitted.
Truth tables are omitted. Yeah. Yeah. I think that's the only thing. Yeah, every other skill you've learned throughout the course, you actually need to know to solve this exam. And all of the skills that you needed to do truth tables, which is mostly just having memorized the truth tables of the connectives, you need in order to do this stuff. So, other questions about invalidities? So this is not a super exciting class. I'm sorry, but I hope it's helpful to go through this stuff in detail. Yeah. Sorry. So invalidities and expansions, the invalidities are worth 2 apiece. I think there's 3 of them. And the expansions are worth 4 apiece, and I think there's also 2 of them. Does that add up? So 14. I think there's 2. So I believe there's 2 expansions, meaning there's 8 points for invalidity. So there are 4 invalidities. 4 invalidities and 2 expansions. Yeah. Okay. Other questions? Okay. Okay. So then finally, a couple of expansions. Provide expansions of the following arguments, as well as a model which shows that they are invalid. That last sentence is asking you to do the invalidity for them. So these things that we're doing with invalidities, the answer to an invalidity is called a model. I'm not sure if I mentioned that, but that's what it's called. Mathematicians, again, will be super familiar with models. So this is just saying do the expansion and then use the expansion to do the invalidity. Is that clear? Okay. Okay, so and it'll look like this. So for the expansions, I'm giving you the universe of discourse. Otherwise, you wouldn't know how far to expand it. So for the expansions, you get given the universe of discourse, and then your only job is to do the expansion. And there'll be like expansion of premise 1 and then a big space, premise 2, big space, conclusion, big space, where you'll do the expansion, and then you can use that to do the invalidity, which is just filling in what happens under the predicates. Yeah? Do you want to do this one? Let's do it, might as well. Okay. That's the one I just said we're doing, right? I hope so. Okay. So, and our universe of discourse is, as I said, 0 and 1. Okay. So, expanding premise 1. Recall that we expand a universal just by replacing the variable everywhere that it appears with first one object and then the other. So, exists a y such that f0y or fy0 brackets, and exists a y such that f1y or fy1. And then we expand the expansion. So, bracket f0, 0. Okay, so with this existential, because this existential has scope over the whole thing, we expand both of these. So we say f0, 0 or f0, 0. Bracket, or f01 or f10. And then we'll expand this thing. F10 or F01 or F11 or F11. Bracket. Okay. So there's premise 1 fully expanded. If you want to be nice to your TA, you can draw a little box around your expansion, to your final expansion, to make sure that they know what it is. Okay, now expand the conclusion. So premise 1, expand the conclusion. So exists a y such that F0y and there exists a y such that, I suppose I don't need those brackets, it's fine, F1y. Expand that, so F00 or F01 and F10 or F11. Okay. So that's the expansion. Now, to do the invalidity, we just need to figure out what goes under the F predicate. It's going to be some set of ordered pairs that makes the premise true and the conclusion false. So how are we going to make this premise true? Oh yeah, and here's, again, this is just for my own note-taking. This isn't me writing down the answer. I do this by just writing down all the possible ways and then putting true or false under them, all the possible assignments. In this case, I've been nice, and it's just one predicate. OK, so we need to make this premise true, which means we need to make both lines of this true. So we need at least one of F00 or these two, and at least one of this thing. So that looks pretty easy to do. It looks like we can make that true in a variety of different ways. So because this looks easy, I'm going to go try to figure out what makes the conclusion false first, and then go back and see if I can make the premise true in a way that's consistent. So to make this thing false, I just need to make one of the conjuncts false. But to make one of the conjuncts false, I need to make both of these disjuncts false, either this set or this set. OK, so let's just pick a set, see what happens, and then go back and fix it if we messed it up. So let's start by making F00 and F01 both false. Let's see what happens. OK, so if that's false, then this conjunct is false, and F10, we could make this thing true by making F10 true. That would be enough to make this whole line true, right? So if I make F10 true, that makes this whole thing true. And it also makes this line true, because F10 appears again here. So this is just a series of disjunctions. Any one of these is enough to make the whole line true. So F10 makes this thing true. And it looks like it doesn't matter what we assign to F11. You can probably pick true or false, and it doesn't matter. Let's just assume false, yeah? Assume false, nothing bad happens. Is that right? Yeah.
So which part of this is model?
So the model is the following. The model is the ordered pair of 1 and 0. That's it, just what's in that. It's just, a model is just an answer to an invalidity. Yeah. So this is called, I mean, this part of logic is called semantics, or model, like models in semantics. So a model is an entity within semantics. Semantics are ways of filling out the possibilities. Yeah?
In exams, is it we choose the model?
You choose the model?
We pick just 0 at 1, and it will be given all.
That's right. So this is, I mean, this is part of the answer. So doing the invalidity is what I've been calling it. So giving me what's the extension of what goes under the F predicate is part of the answer to this. Yeah? So again, just to show you what, remind you what this looks like, this is what you'll see on the exam. So there'll be an argument. I will give you the universe of discourse, and it's up to you to fill in what goes under the F predicate. And just as a matter of strategy, if you can just see what goes under the F predicate before doing the expansion, feel free to do that part first. I find it much, much easier to figure out what's going to go under that F predicate after I've done the expansion. I use that as a tool to figure out how to solve the invalidity. So your answer will be the expansion and the solution to the invalidity, which is called a model. Yeah? Okay. So just in case you were, I know people like to take pictures of this. Any questions about this? About how to do these things in general, or this question in particular? Now is the perfect time. It's not a bad time. Okay. Just one last thing to note, the derivations. Let me confirm that there are, in fact, 1 basic and 3 derived. Let me double check that. I believe that's correct, but I will make a note about it on Quarkus. Yeah. Okay. So just to remind you of the rules for basic rules derivations, you cannot use CDJ, DM, NC, NB, SC, QN, or AV. Those are all derived rules. You can use, those are the basic rules, and you'll get lists. Just like with the first 2 tests, you'll get lists of the allowed rules. That'll be at the top. So at the top of the sheet, it'll just look exactly the same as it did on test 1 and test 2. There'll be an argument for you to derive, a list of the available rules. And just to reiterate, I think I said this before test 2, but universal derivations are considered part of the basic rules package. In some sense, they're not really a rule, they're a derivation type. So just like you're allowed to use CD and ID in basic rules tests, derivations, you're allowed to use UDs. But the TAs asked me to reiterate just one thing, because a number of people had problems with this on test 2. When you're doing a universal derivation, you have to make sure that the variable that you're doing the UD to, so the show line, you say show this universal, the variable that appears in that universal has to be arbitrary. And arbitrary means it hasn't appeared free, which is to say it hasn't appeared without a variable binding or a quantifier binding it. It can't appear free on any line that's above you, on any available line above where you're at in the test, or in a premise cited in an available line. So those are the rules on arbitrariness. And that was kind of baked into how universal derivations are supposed to work, right? You're not supposed to start off with a bunch of knowledge about the object and then start a UD, or knowledge about the variable, and then start a UD about it. You need to start a UD about something that you don't know anything about. Okay, so just keep that in mind. You can review the lectures on this stuff if that's unclear. Any final questions before we call it a day? Okay, all right. Good luck on the exam, everyone, and thanks very much. Oh, thank you, thank you. Thank you for your patience with me. It's been wonderful. Okay. Okay.